All right, let's look at the homework 13.2, problem number 8. All right, so let's evaluate this integral here. All right, so the first component is antiderivative of secant squared, so it's going to be simply tangent. So we have tangent of t plus some constant, maybe I'll call it c1. Right? Then we have vector I. Right? Then we need to evaluate the integral of t times t squared plus 1 to the fourth dt. Right? So let's do this separately. Right? So I'm going to use a substitution. Let u be t squared plus 1. Alright, then if you take the derivative of u with respect to t, then you're going to get 2t. Right, then I'm going to take the reciprocal of both sides. We have dt over du is equal to 1 over 2t. Alright, then we're going to multiply through by du, so that we have an expression for dt, which came out to be du over 2t. Alright, so this is going to be rewritten as, right, so you have an integral, right, I'm going to leave t as it is, right, then we decided to call this guy u. So we have u to the fourth power, and the dt is can be rewritten as a du over 2t. Right, now we can cancel t on top here and t on the bottom. Alright, so we can, let's see, clean up a bit. Alright, 1 over 2, so that's a constant, so put it outside. Right, then we have an integral of simply u to the fourth du. Right, so using the power rule, right, add 1 to the power, so u to the fifth, then you divide by 5. Right, so you have plus some constant, you have to use C2. Alright, so this is going to be, right, so we have a 1 over 10. Then u is originally t squared plus 1, so raise it to the fifth power, and then you have a C2. Alright, so we're going to have, right, we found the second component, which is 1 over 10. I guess I have to use a different kind of bracket here. Right, so this is going to be, right, t squared plus 1 raised it to the fifth power, and then plus c2. Right, times vector j. Alright, and the last one, we're going to have to integrate. Alright, I'm going to actually write natural log of t first, and then I'm going to put the t to the 8 dt. Alright, so I'm going to take, so we're going to have to use integration by part. I'm going to take this guy as u. And maybe I should use a different color here. All right, I'm going to take this guy as u and the rest as dv. All right, so we're going to get this. All right, so I'm going to say let u is equal to natural log of t. All right, then you can take the derivative of u with respect to t, which is going to be just 1 over t. Right, so this is going to be du is same thing as dt over t. Right? Then since dv is equal to t to the 8th dt, right? Then we divide through by dt, you get dv over dt is equal to t to the 8th. By taking the antiderivative, we can find the v, which is going to be t to the 9th power over 9. All right, then we need these guys, so we need the u, and we need the du, and we need v. All right, so find the integration by parts. First, you have uv, so we're going to multiply t to the 9th over 9 and the natural log of t, right, minus integral. Right, then you have dt, so I'm going to put the dt. All right, so it's over t, so it's going to be t to the 8th power, one of them cancel out, over 9. Right, then you're going to end up getting, so this is going to equal to, right, so you have a t to the 9th over 9, natural log of t, right, minus, right, so raise, okay, t to the, add 1 to the power, so it's 9, over, divide by 9, but 9 was already there, so 9 times 9 is 81. And then you have a plus some constant I'm going to call C3 or something like that. All right, so if you want, we can probably pull out t to the 9th over 81. That way, you're going to have extra 9 here, natural log of t, minus 1, plus some constant, the C3. All right, so we got this third component. So you have a t to the 9th over 81. Then you have a 9 natural log of t minus 1. And then plus some constant C3. Then you have a vector k. All right, so let's type this guy in. All right, so what we got was here. Actually, the constant c, this is a vector, so c1, c2, c3. So you have that. So we just have to put the expression. So first one is, so it's going to be a vector, right? So it's going to be tangent of t. All right, comma. And next component is, I'm going to put t squared plus 1. Oh, actually, oops, there's a t. All right, plus 1. And raise it to the 5th power and divided by 10. Right? And then third component is t to the 9th power. And then you have 9 natural log of t minus 1. Then we divide it through by 81. Right? Then put right, close that. Alright, so that's the integral. So let's actually yeah, let's try this. Let's submit for testing. Alright, I came back and looks like we got this one correctly. If you want, we could put tangent of ti and t squared plus 1 to the 5th over 10 j and so on, but this notation works as well. Alright, that's it. I hope that this was clear.